So this question here, it says find the length of BD. Okay, now it's quite complicated looking sort of shape here, isn't it? And you've got actually a triangle within the triangle, haven't you? It can get confusing. But to get BD, alright, BD, if you think about it, is part of both triangles, isn't it? It's part of the large triangle and the smaller triangle, okay? The large triangle and the smaller triangle. So one thing I'm thinking of is if we look at the large triangle, okay, I might actually do a quick sketch of the large triangle here. Okay, we'll see a scaled down version. So that would be ADB, right? So that's a large triangle. We know this is 80 degrees here, okay? And we know this side is 12.1, and we know this side is 8.7, okay? We can work out DB, can't we? We can use the rule, we can use the cosine rule, yeah? So if you just ignore this here, this bit, we can use the cosine rule here, because you know two angles, you know two sides and the angle in between them. So the cosine rule then will be, you know, you want little a, won't you? So using the cosine rule, it'll be a is what you want, little a. So then remember it's b squared plus c squared, but of course in this case we'll have b and d, isn't it? So b squared plus d squared minus 2bd cos of angle a, okay? So we put that as a squared. B then will be 8.7 squared, d is 12.1 squared, take away 2 times b times d times then cos of angle 80. So you get a squared out, so I type that in all in one go. This comes out to be that 185 point something. To get a then, of course, you just need to square root that answer. Take the square root the answer. 13.6 centimeters, if I've done it right. Okay. So we now know, if we go back to the bigger sort of picture here, we've got that. Okay. So part A is answered. Part B then says calculate the area of the quadrilateral ABCD. Now, if you look at the quadrilateral, A there, B, C, D. It kind of forms like a sort of like an arrowhead, isn't it? Kind of shape. Quadrilateral, of course, got 4 sides, and they want this area. Now, there's no formula as such, isn't it, for this? I wonder if you meant to work it out. Well, you might notice that actually this bit here, right? This you can shade it in if you want, we really want to. Okay. It doesn't confuse things. Okay, that area there is what they want, the area of the quadrilateral. Is just like basically doing the area of the big triangle, take away the area of the small triangle. Yeah, because you're cutting out the area of that small triangle. Now we can work out the area of the big triangle, okay? Right, because of course we know the formula, half times these two sides, isn't it? Because the angle's in between them, those two sides, angle in between them. So times 12.1 times 8.7 times sine 80. And that comes to 51.83 5, right? If I'm doing this right, hopefully, you know, no mistakes here. Then area then of the small triangle. Now you might think, what am I doing? Well, if we look, as I said, we look at the area of the big triangle here, right? Cut out the area of the small triangle. We get the area of this shaded bit here, the quadrilateral. Now the small triangle, again, look, we've got that angle and the two sides between them. So, two sides either side of the angle. So, we do exactly the same. Half times 6.3 times 13.6 times sine 25. You get 18.105, and then of course all you got to do then to finish off is you take away. Okay, so 51.835, so ABCD area, take away 18.105, and we get 33 point, we go for one decimal place because all the lengths given one, yeah, 33.7 centimeters squared.